Okay, let's see. 32. Oops. Find the right 32. Alright, we have an area problem here. It says find the area in terms of k of the region bounded by y equals x to the fourth and y equals k, assuming that k greater than 0. Right. And so the picture here, and of course we have a calculator for this, so we can look at it if we don't know for some reason, but we have an x to the fourth function, and we have some line y equals k. And so again, we're looking for the region enclosed by, or excuse me, the area in terms of k for the region enclosed by these two graphs. So we know that we're going to get an area here of the k function minus the x to the fourth function. The top function is the k, the bottom function would be the x to the fourth. And then the issue here is what about these limits? Well, the limits are going to be the intersection points of these two. And so if x to the fourth would equal k, and we solve that for x, we're going to get x equals the fourth root of k, plus or minus. So it'll be negative fourth root of k, fourth root of k. Will be our integral. Questions so far? Integrating would get kx minus x to the fifth over 5. And if we plugged in our results here, we get k fourth root k for the first part. And then if we raised the fourth root of k to the fifth power, well, what's going to happen with that? If I multiplied this by itself 4 times, I'd get simply k, wouldn't I? Or you're right, k squared. No, just k. Okay, this would just be k if we did it 4 times. Remember, k to the x to the fifth means we're multiplying it by itself 5 times. So multiplying this by itself 4 times would get me to k. And then one more would be k times this. So we'd ultimately get minus k fourth root k. But remember, that's also over what? 5. So by putting the fourth root of k into this, we're going to get that expression. And then from there, we're going to subtract. If I put a negative 1 in there, we're going to get negative k fourth root of k. And then plus k fourth root of k over 5. And in doing the math on that, we're going to get plus plus here, so we're going to get 2k fourth root of k. And then this one we're going to go minus this, and then it's going to be minus this, so it's going to be minus 2k fourth root of k over 5. And ultimately, if I want to add these together, we're going to get, we have pretty much like terms here, so if we made this 10 over 5 minus 2 over 5, it'd be 8 over 5, k fourth root k. And that looks like it matches up with 1.6, which should be letter D. And remember, k fourth root k would be same as k times k to the 1/4, which would be k to the 5/4. That's why it's 1.6 k to the 5/4 as your choice. That part right there is the k to the 5/4 part. 8/5 would be 1/3 or 1.6. So that's why we get letter D. Questions on that one? What else? Calculator part. 31, we have a area enclosed by the line y equals 2, the parabola 6 minus x squared. So we got 6 minus x squared, line y equals 2. And we're going to revolve that around the x-axis. So revolving around the x-axis, if I took a vertical slice, that would give me washers. So my washer setup here would be the pi times the outside radius would be the top function, 6 minus x squared, minus the inside radius, which would be the 2 function, squared. And now the only other issue is, what about the limits here? The limits here are going to be the intersections of these two. And so if I set 6 minus x squared equal to 2, I get 4 equals x squared. So it'd be plus and minus 2 would be our x's. And once we get that washer set up correctly, then just calculate a problem from there. And looks like I said E. It should turn out to be 241.3. And the key issue is it's a washer problem because we got a vertical slice perpendicular to the revolving line, the x-axis. Okay. Outside radius is the top function, so outside radius squared minus inside radius is the bottom function. And if we set that up properly and then calculate it, it should be 241.3.